Yes, circuits in under-slab floor boxes should have ground fault circuit interrupter, or GFCI, protection. This is because under-slab locations are often considered wet locations, and the National Electrical Code, or NEC, requires GFCI protection in wet locations to enhance electrical safety. A GFCI is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault within as little as 1/40 of a second. It works by monitoring the amount of current flowing from hot to neutral. If there is any imbalance, meaning some current is leaking to ground, the GFCI trips the circuit. This prevents electrical shock. The NEC specifies GFCI protection in various locations where there is a higher risk of electric shock, including bathrooms, kitchens, garages, outdoor areas, and, importantly, wet locations. An under-slab floor box, by virtue of its location, is susceptible to moisture and dampness. Concrete slabs can wick moisture from the ground, and condensation can form within the box. This creates a hazardous environment where electrical components can become energized, posing a shock hazard to anyone who comes into contact with them. The specific requirements for GFCI protection can be found in NEC Section 210.8. This section outlines the locations where GFCI protection is mandatory for personnel. The rationale behind requiring GFCI protection in wet locations is to provide an additional layer of safety beyond standard circuit breakers. Standard circuit breakers protect against overloads and short circuits, which can cause fires. However, they do not protect against ground faults, which can cause electric shock. A ground fault occurs when current flows through an unintended path to ground, such as through a person's body. GFCIs are designed to detect these ground faults and quickly interrupt the circuit, preventing serious injury or death. When installing an under-slab floor box, it is crucial to use wiring and components that are rated for wet locations. This includes using THWN or XHHW type conductors, which are moisture resistant. It also means using a weatherproof floor box enclosure that is designed to prevent water from entering. In addition to GFCI protection, it is also important to ensure that the floor box is properly grounded. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip the circuit breaker in the event of a ground fault. The grounding conductor should be connected to the grounding terminal in the floor box and to the grounding electrode system of the building. The size of the grounding conductor should be determined based on the size of the circuit conductors, as specified in NEC Table 250.122. Furthermore, all electrical connections within the floor box should be made using approved methods and materials. Wire connectors should be suitable for use in wet locations and should be properly tightened to ensure a secure connection. Loose connections can cause arcing and overheating, which can lead to fires. When selecting a GFCI device for use in an under-slab floor box, it is important to choose one that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, OIL. This ensures that the device has been tested and meets safety standards. GFCI devices are available in several different types, including GFCI circuit breakers and GFCI receptacles. A GFCI circuit breaker replaces a standard circuit breaker in the electrical panel and provides GFCI protection for the entire circuit. A GFCI receptacle is installed in place of a standard receptacle and provides GFCI protection only at that location. For an under-slab floor box, either a GFCI circuit breaker or a GFCI receptacle can be used. However, a GFCI circuit breaker may be a better option if there are multiple receptacles or other electrical devices connected to the circuit. It is also important to test the GFCI device regularly to ensure that it is working properly. GFCIs have a test button that can be used to simulate a ground fault. When the test button is pressed, the GFCI should trip and interrupt the circuit. If the GFCI does not trip when the test button is pressed, it should be replaced. In summary, GFCI protection is required for circuits in under-slab floor boxes because these locations are considered wet locations. GFCI protection provides an additional layer of safety by detecting ground faults and quickly interrupting the circuit. When installing an under-slab floor box, It is important to use wiring and components that are rated for wet locations to ensure that the floor box is properly grounded and to test the GFCI device regularly. The NEC is the primary source for electrical safety standards in the United States. It is updated every 3 years to reflect changes in technology and best practices. Electrical inspectors use the NEC to ensure that electrical installations are safe and comply with code requirements. Following the NEC guidelines will help to minimize the risk of electrical shock and fire. When working with electricity, it is always important to exercise caution and to follow safety procedures. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Firstly, ensure that you have the correct tools and materials for the job. Secondly, always turn off the power to the circuit before working on it. Thirdly, use a voltage tester to verify that the power is off. Fourthly, never work alone. Fifthly, wear appropriate personal protective equipment, such as safety glasses and gloves. Sixthly, follow all instructions and safety guidelines provided by the manufacturer of the electrical equipment. Seventhly, if you are unsure about anything, ask a qualified electrician for help. Remember, electricity can be dangerous, but by following safety precautions, you can minimize the risk of injury or death. Always consult the latest edition of the NEC and local electrical codes for specific requirements in your area. Local codes may have more stringent requirements than the NEC. For example, some jurisdictions may require arc fault circuit interrupter or SI protection in addition to GFCI protection in certain locations. SIs are designed to protect against arcing faults, which can cause fires. GFCI protection is not a substitute for proper wiring practices and grounding. It is an additional layer of safety that should be used in conjunction with other safety measures. The intent is to provide enhanced protection against electrical shock in environments where the risk is higher due to moisture or other factors. Therefore, always prioritize proper installation and maintenance of electrical systems to ensure safety and compliance with all applicable codes and standards. Remember to consult with a qualified electrician for any electrical work you are not comfortable performing yourself. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. The NEC also addresses the use of listed or labeled equipment. This means that any electrical equipment used in an installation must be tested and certified by a recognized testing laboratory. This ensures that the equipment meets safety standards and is suitable for its intended use. When selecting electrical equipment, look for the UL listing mark or other recognized certification mark. The listing mark indicates that the equipment has been tested and meets the requirements of the applicable safety standards. Using listed or labeled equipment is an important part of ensuring the safety of an electrical installation. In addition to GFCI protection and proper wiring practices, it is also important to maintain electrical equipment in good condition. Regularly inspect electrical cords and plugs for damage. Replace any damaged cords or plugs immediately. Do not overload electrical circuits by plugging too many devices into a single outlet. Overloading a circuit can cause a circuit breaker to trip or can even start a fire. If you notice any signs of electrical problems, such as flickering lights, sparking outlets, or burning smells, have the problem investigated by a qualified electrician immediately. Ignoring electrical problems can lead to serious safety hazards. Furthermore, be aware of the potential hazards associated with using extension cords. Extension cords are intended for temporary use only. Do not use extension cords as a substitute for permanent wiring. If you need to use an extension cord, choose one that is rated for the amperage of the device you will be plugging into it. Do not run extension cords under rugs or furniture, as this can cause them to overheat. Inspect extension cords regularly for damage and replace them if necessary. In addition to the NEC, there are other resources available that can help you learn more about electrical safety. The Electrical Safety Foundation International, or ESFI, is a non-profit organization that provides electrical safety information to consumers and businesses. ESFI offers a variety of resources, including articles, videos, and training programs. The Occupational Safety and Health Administration, or OSHA, also provides information on electrical safety in the workplace. OSHA has regulations that employers must follow to protect their employees from electrical hazards. These regulations cover a wide range of topics, including lockout/tagout procedures, personal protective equipment, and training requirements. By following these regulations, employers can help to create a safe work environment for their employees. Electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents. By being aware of the hazards and taking precautions, we can all help to make our homes and workplaces safer. Remember, when in doubt, consult a qualified electrician. Electrical work can be dangerous, and it is always best to leave it to the professionals. Proper GFCI installation is crucial for safety in wet locations like under slab floor boxes.